The death of single-core solution. For increasing the speed of the processor, the most common solution is to increase the clock rate. Today's modern processors have clock rate of around 4 GHz. But increasing much clock rate ultimately generates too much heat and the power consumption is also increased. The solution for this problems was adding cores to the processors instead of continuously trying to increase clock rate. Due to this solution, we could have dual, tri, quad, hex, 8 or 12, 16, or even 32 cores to processors. Both the GPU and CPU get benefited by this solution. The software industry took years to work on the multi-core platform as programmers need to learn how to execute multiple modules on the multiple core. NVIDIA and CUDA. NVIDIA Corporation is an American global technology company. This company manufactures GPU, graphics processing units. What is this GPU? The GPU is a computer chip that performs rapid mathematical calculations, primarily for the purpose of rendering images. Forbes magazine named NVIDIA its Company of the Year 2007. CUDA is a parallel computing platform and programming model created by NVIDIA and implemented by the GPUs. The CUDA stands for Compute Unified Device Architecture. CUDA is an extension C language that allows GPU code to be written in regular C language. The code can be either written for host processor CPU or for device processor GPU. The host processor can spawn a multi-threaded task to GPU device. CUDA is widely applied in the areas of data mining, telecommunication, finance, data analysis, statistical analysis, biological medicines, military simulation. Advantages of CUDA. CUDA has several advantages over traditional general-purpose computations on GPU using Graphics API. The code can read from arbitrary address in memory. CUDA exposes fast shared memory region that can be shared among the threads. The downloading and reading from and to GPU is fast. Full support for integer and bitwise operation. Limitation of CUDA. CUDA-enabled GPUs are only available from NVIDIA. It is a US-based corporation. OpenGL can access CUDA memory, but CUDA does not have access to OpenGL memory. Threads should be running in groups of at least 32 for best performance, with total number of threads numbering in the thousands. Branched in the program code do not affect performance significantly. No emulator is available for modern revisions. C++ runtime type information, RTTI, is not supported in CUDA code, due to lack of support in the underlying hardware. Exception handling is not supported in CUDA code due to performance overhead that would be incurred with many thousand of parallel threads running. GPU hardware. As we know, GPU is for performing graphics-intensive applications. Each GPU hardware consists of memory. The memory can be global memory, shared memory and constant memory. Streaming multiprocessors SM. Streaming processors SP. The SPs execute work as parallel sets up to 32 units. These SPs actually eliminate the need for complex circulatory, which is required in CPU to achieve high-speed execution. The most important feature of CUDA is that even though there is variability in hardware, programs written for original CUDA devices can run on today's CUDA devices. Alternatives to CUDA. Although CUDA is used for high-performance multiprocessing implementations, there are several alternatives available for this purpose. OpenCL. OpenCL is framework for writing programs that execute across heterogeneous platform consisting of CPU, GPU, digital signal processors and other processors. The OpenCL stands for Open Computing Language. It has been adopted by Apple, Intel, AMD, NVIDIA and others. Direct Compute. The Direct Compute is an application programming interface API from Microsoft. It supports general-purpose computing on GPU. DirectX 11 is supported under Windows 7. The latest release DirectX 12 will also be supported on later NVIDIA GPU. The CUDA applications can be easily ported over Direct Compute.